into your calculator. You've plugged in your numbers to help you find your zeros so we don't have to work so hard. If you did it all by hand, can you do that? Absolutely. There's nothing wrong with it. What were the numbers you were plugging in? I forgot to go over that. Factors of 20 divided by 1, correct? So you're plugging in 1 and 20, 2 and 10, 4 and 5, right? All plus and minus. Okay, so you plugged in all the positives, none of them worked, correct? So you plugged in -2 and you got this. Everybody happy?
Yep.
Okay, when you do -2, what can I do with the 1, -6, and 10?
You can make it into a quadratic.
That's a quadratic. Very good. So this is x squared minus 6x plus 10. Will the factors of 10 give you 6?
No.
No. So you have to use the quadratic formula, which is what? Opposite of e plus or minus square root of
b
squared minus.
c all over 2
Okay, what's 36 minus 40?
-4.
-4. So since that's a -4, will any of the rest of my lists work? No. So there's only one real one. What are these two?
Those are imaginary.
They are imaginary. How do we write them?
I.
Yep. 6 plus or minus what?
I.
What kind of I?
I squared.
What's the square root of 4? 2. So it's 2i all over 2. Can that be reduced further?
Yeah.
Yeah. Into what? 3 plus or minus I. Everybody okay?
Yeah.
All right. Everybody happy? Okay, good. Could you do it all by hand if you wanted to?
Yeah, but
Yes, you could do synthetic. All these.
I want to remember how to type that.
Hold on.
The beast.
It is. All right. Now, today we're doing this. And it's the same thing on the calculator. Quiet. You are looking to graph this. I want to find the min and the maxes and all the rest. So I have to find where it crosses the x-axis, and I have to find my relative mins and my relative maxes. I did it on the last chapter. All from the graph. I'm only going to make you do it to the nearest whole number. All right? When you get to calculus, they make you do it to the nearest 10. Some of them make you do it to the nearest 100, depending how evil your teacher is.
There's thousands, so
Yeah, always good. We're doing hundreds. Now, things you need to know. When you're typing this in your calculator, all of your roots will fall between the first and the last number multiplied. So -3 times 5 is what?
-15.
So all of your roots fall between -15 and 15. They're called your bounds. Your boundaries. That's where they have to fall. All the real and the imaginary fall there. They are always way too big. Okay? So when I type in -15, so you would type this into your calculator like you just did. You call it, I don't even care, g of x. All right? Or you could use synthetic substitution. It will do the same thing. So if you want to do it by hand, that's fine. You could use your regular calculators to do this. Right? And just replace the x every time with the negative numbers or your numbers. It all works. It's just that our calculator does it faster. All right. So when you plug in -15, it's ridiculously large. All right. So you need to drop down until a number makes sense. That's all you do. It's like yes and check. But that's a starting point. When you look at this, what's a -3x³ graph look like? Starts how, ends how, can cross how many times?
3 times.
Starts positive, ends negative, can cross 3. So it can look like so. Agreed? Okay, it could cross 3 times, or it could cross once. When you're doing this, if you don't know what the graph looks like, you don't know if you're in the right spot. So what you're doing is I'm starting with a really high number here, a high positive number. Agreed? And I need to go down. So if I'm not starting with a high positive number, I'm not far enough over on my graph. Fair enough? Because if you started at 0 and I started with 5, that's not high enough. So you know you need to go backwards until you find a high positive number. So when you plug in -15, it's a ridiculously high positive number. You know you're on the right spot. Good? questions on that? Alright, so I dropped all the way down to -4. Because -4, right here, when you type it into your calculator, is -325. Or positive, sorry. Ridiculously high number. Agreed? Alright, then I keep going until I can graph. Because -3 gives me 158. Still too high. But I'm on the right track. I dropped by a good amount. Agreed? -2, 61. Okay, I'm looking for a direction change. So there's two things you're going to look for. A direction change and a sign change. What will a direction change tell you? So if I'm going down and I start to go back up, what have I found? I found a min. So if I'm going down and I start to go back up, I have found my min. If I'm going up and I start to go back down, I found my max. What happens from here to here? What will I see in my graph? A what number? A positive number to a negative. So you're looking for a direction change for max and min. You're looking for a sign change for your zeros. Good so far? Mm-hmm. Okay. So I'm going 325 to 158 is down. I have no direction change yet. 158 to 61, down. 16 to 5, down. 5 to 10, up. That is a direction change. So in here, I was going down. Now I'm going up. So what did I find? A min. This is a relative min. This is what you look at. This is where it happens. All right. So I have a relative min between 0 and 1. Do I know exactly where?
Nope.
Do I care?
No.
No. Relative min between 0 and 1. Good? Okay. So now I'm going up. So now I'm going to look for a direction that's going back down. So 10 to 13 is up. 13 to -4, down.
So that's your max.
So that's my max. Relative max between 2 and 3. Are we good so far? Okay, so I've used my numbers to find my max and min. Now I have to use them to find my zeros. Now, my zeros are what crosses the x-axis. So I'm looking for what now? Sign change. Or it could equal 0. So, right here, I'm going down and up. Did I ever cross the x-axis? So those two are imaginary. Where do I cross the x-axis? 13 and -4, right? So in here, not only do I have a relative max, I also have a...
Why'd you say 13 and 0?
13 and -4. I went from a positive number to a negative number. Okay, what?
I was just thinking 40. I wasn't thinking 13 and
Nope, this tells me what happens. Over here is where it happens. Okay?
But is
So-
3 -4 a point?
Yes.
That's what I was thinking. Like, that's what it changes. 3
We don't know where it changes. It changes between 213 and 3 -4, but I don't know where. It's in there somewhere.
Well, we better get this slope. There's that form going.
Well, if it was a line, maybe that would be helpful. But since it's not going to work. Not that either, because you're at a cube. Okay, so in here, since it changed sign, I also have a root. Okay, so this is a relative max and a root. Two things happen here. Will that happen often? Generally they're going to be separated out, but it can. Okay, direction change gives you max and min. Sign change gives you roots. Now we got to graph this thing.
Yeah.
So, -116, already graphed. 0, 5, 1, 10, 2, 13, 3, -4. Down here. So that means this goes down like this. It's a min in here somewhere. So it goes past it and then back up. My max is in here somewhere. Don't know where. And then goes back down and hits there. So my max shows up here And my root shows up.
It's like a heartbeat thing.
Yeah, it's pretty poorly drawn too.
Die.
Okay, I need what do you like, what don't you like?
See,
Or is it okay?
don't like it.
I just don't like it, but I understand.
Understand you. Go ahead, Denton.
Where do you get like the 15?
The 5 and the negative 3.
Take 5 times negative 3 from the top.
So do you have like do?
I don't even see a 15. What are we talking about?
15 and
Oh, up
negative
here.
15.
This tells you where you can start. That's from the first number times the last number. It's a very big range, is what it does. So I know nothing is going, between negative 15 and 15 is where all the roots have to fall. These are always too big. Absolutely always. All right? We just don't know how much too big. But it's a place to start. So when you plug in the negative 15, that one was ridiculous. Like, probably would sit on your calculator. Ridiculous.
And you just find one until you like grab one.
Yep. You do. You keep going until it makes sense.
So you took what's in the exponent, you know, -4, -3, -2. Like,
Yep.
Took it from between -15
Yes.
and 15.
Yes.
So then you plug that into the equation, -3x3.
Yes. So these numbers are being plugged in here. When I plug in -4, so I'm using synthetic substitution, it gives me 325. So if you don't have my calculator at home, it doesn't matter. You can still do it. If you plug in -3 into the x's, you're going to get 158.
I'm
Yep.
just confused on minimum and maximum.
That
Why isn't necessary? Because you have 2 and then negative.
no, it's between 2 and 1. That's 2 is in here. It's
So-
a dash. It's between 2 and 3. So when you graph, it's spelled between 2 and 3.
Okay.
Okay, next question. All right, you have one to try. My other class, oh, there's the answers, darn.
Oh,
Get rid of these.
Oh, hold up there. I want to copy
And
that.
done.
I need
Yeah.
to copy something up there.
All right, try yours. And the last class was pretty much done with the calculator, so you did not want to know how to do this on the calculator. Are you the same way?
I kind of like it on the calculator.
Kind of like it? All right, you do it by hand. All right, you do it this calculator method, and then the ones who want to learn how to graph on the calculator, I will show you.
Right here, right here.
But first, I want this done.